Find the doubling time in a bank offering 9% nominal interest rate compounded daily. So read questions carefully. The key is to work with factors. Each day money increases by a factor of 1 plus 900ths over 365, because you get 9 over 365% each day, and expressed as a real number, that's that. So the factor is that plus 1. So we introduce a letter for the unknown quantity, t say. You get your equation, whatever x is, you take logarithms after dividing by x, and the t can jump down. And this is the answer. If you use a calculator, it's approximately 2811, and that's days. So use factors and read questions carefully. Be careful when you find the relevant factor. Next topic, suppose you have a loan at 1 per mille, weekly interest, compounded weekly. Again, read questions carefully. So the interest rate is 0.001, expressed as a real number. The plan was to pay this back by paying, to become debt free by paying $154 in 3 weeks time, $227 in 15 weeks time. But suppose you want to make one single payment of $381. When should it be done? Again, as in many questions, the key is to find the relevant factor by which money grows each week, compounded weekly, so your period is a week. In this case it's 1 plus 0.1 over 100, or 1.001. Then you make a timeline. So this is a very strong combination, these two. Here's your timeline. You had these two. So the recipe for equated time is to first find the total present value. So you take these two, you move them back. This guy is moved back 3 steps. So its present value is 154 divided by the factor of 3 times, and this, so use a calculator, is 377.16. Don't round off in middle stages. Right, so once you have the present value of the total stuff, you ask the question, how many steps forward do you go before it's 381? This unknown quantity is t, say. You get the equation 377.16 times the factor to the power of t is 381. Move over, take logarithms. Use calculator if you have time. This is in weeks. It's okay if it's not an integer. So again, key, identify the relevant factor for your period, draw a timeline, move things around as you need to move them around, and profit. Here's just a geometric series. So how do you apply the formula? You identify what is a, the starting term is x4. What's k? What do you need to multiply this by to go to the next one? x3, so that's k. How many times do you multiply by k? That's x3 to go from the first one to the last one. Well, the last one divided by the first one is x30, so x30 over, well, I mean, k to the power of 10 is x30, so n is 10. And now we apply the formula. The sum is the starting term times this fraction, k minus 1, k to the power of n plus 1 minus 1, and it comes out as this. It comes out as whatever it comes out as. Right.